Hi, in this video we're going to look at an example from section 2 of module 3. As you can see, this is going to be our first example. We're going to do several examples from this section. And in this example we're going to do an outstanding balance with something called a drop payment. So let's look at the example. We got a loan of $100,000 at a monthly effective interest rate of 0.5%, is repaid with regular monthly payments of $1,000 and a final smaller payment 1 month after that last regular payment. So the question first, this first question is to determine the outstanding balance immediately after the 50th regular payment. So I'm not sure that I even need a timeline for this particular problem. So let's just kind of get into the solution. I want the balance immediately after the 50th regular payment. That's that cap B sub 50 that we use. And the way you calculate the balance, we could remember there's a retrospective and a prospective calculation of balances, of calculating balances. If I try to do something prospectively here, I mean, think about what information is given to you and what information you need in order to calculate retrospective and prospective balances. So if I was looking prospectively, remember prospectively is that the balance after the 50th payment would be the present value of the remaining payments. Well, the problem here is I don't know how many payments I have. I wasn't given that information. I could figure it out, but I wasn't given that information. So there's going to be an extra step involved. So let's look retrospectively. Well, if I think retrospectively, I need to know, remember retrospectively, the balance after just after the 50th payment would be the accumulated value of the loan amount minus the accumulated value of the past payments. So accumulate the loan amount, that's how much you would owe if you had not made any payments. And then you subtract off the accumulated value at time 50 of the payments that you did make. And I've got all the information there. And this is what I was saying a little while ago. I don't think really that this is very difficult to do. I don't really need a timeline here. The accumulated value of the loan amount, well, that's going to be the loan amount accumulated. so that would be 100,000 times 1.005 to the 50th power. So now I need to subtract off the accumulated value of the past payments. Well, look, the past payments were all level. They're all 1,000. So I'm accumulating, then I'm looking at the accumulated value of an annuity that has payments of 1,000, and I'm looking at the accumulated value at the time of the last 50 payments. And so that accumulated value of the past payments, symbolically, this goes back to the last module, module 2, this would just be a 1,000 times an S angle 50, symbolically. So that's the equation that I have. I'm just trying to solve that for cap B sub 50. Now, I want to make a comment here about using your calculator. At this point, you could do this problem in 2 steps. You have, in the last line here, you have 2 terms in the expression on the right hand side. You could just do that in 2 steps if you want to. However, this is really a 1-step calculation. I want you to get used to being proficient using your calculator, so I want to go over that 1-step calculation. So remember, what you got to do is put the equation in standard form by setting it equal to 0, moving some terms around and setting it equal to 0. What I choose to do on these types of problems is I like to put the payment in as a negative when I'm using my calculator. So I'm going to subtract B50 from both sides, because the payment shows up as that 1,000. That's that number in front of the S angle 50. So I want that 1,000. I'm going to input it as a negative. So I want that minus sign in front of the 1,000. I don't want to move that term to the other side of the equal sign, because then the 1,000 would have a plus in front of it. I'll be having to put the payment in as a plus. So I set the standard equation. I get to the standard equation by subtracting a cap B50 from both sides. That's one of 2 standard equations. The other way is, move things to the other side of the equal sign. But this is how I want to write it. And when I write it this way, then the keystrokes that I would use is as follows. So I'll just give you the keystrokes here. I want to make sure that I'm in the in mode, because that's an S symbol, not an S double dot. So I'll make sure I'm in the in mode. I think it's clear that the in value is going to be 50 and the I/Y is going to be 0.5. That 100,000 You see, it's being accumulated for 50 periods, and since n is 50, I can think of the 100,000 as just the present value. I would input that as a positive because there's an understood plus in front of 100,000 in that equation. And then the payment is going to be a negative 1,000. It's negative because there's a minus sign in front of that 1,000. So I go through these keystrokes and then I compute the future value. And what should the future value, when you compute this, before you do this on your calculator, I want you to think about, well, how is the future value coming out, as a plus sign or a minus sign? And the future value is that cap B sub 50. So in front of the cap B sub 50 is a minus sign. So when I do this on my calculator, it's going to come out as a negative some number, and that number is what that cap B sub 50 is. And I'll leave it to you to go through the keystrokes on your calculator, and you'll see that the balance just after that 50th payment, after you made 50 payments, you still owe 71,000 plus 71,677. Okay, so now let's go back to the original problem. We answered this problem then. So let's go back to the original statement. Instead of the question to determine the outstanding balance immediately after the 50th regular payment, suppose that the question was, determine the amount of the drop payment. Well, I have to tell you what that drop payment is. It's a very easy concept, though. That drop payment is that final smaller payment. So when you're in a situation where you're making a bunch of level payments, and then the very last payment is a little bit less than the other payments, it's called a drop payment. So kind of easy context. So now, how do we calculate the amount of that drop payment? Well, I need to know first how many regular payments of 1,000 would there be. So I would set up an equation where 100,000, that's the loan amount, would equal 1,000. That's what the payments are, 1,000 times an A angle N. N is what I don't know at the 0.5% interest rate, annual monthly effective interest rate. So this is a TVM calculation. Do this on your calculator. This is a compute N calculation, and what you'll see is N ends up being 138 point something. Well, you can't have point something payments. You have 138 payments or 139 payments. What this tells me then is that my timeline ultimately looks like this. I have 138 payments of 1,000 and plus another payment at time 139 of cap Y, and that cap Y is going to be that drop payment. It's going to be less than 1,000, because if it was more than 1,000, I would have gotten a 139 when I computed in a little while ago. But so I know that the cap Y value is going to be less than 1,000. So at this point, well, how do I calculate that cap Y value? Well, it's not, so we go through this process. It's not a difficult process to do. The original problem was to calculate the balance after the 50th payment. Well, the 50 is not really relevant anymore. Now what's relevant is the 138. So let's, because I got 138 payments of 1,000. So if I look at time 138, I can calculate the balance at time 138. Like I did before with the balance at time 50, I can calculate that. But now I want to know, well, what's the value of cap Y? What's the payment at time 139? Well, that would be the balance at time 138 accumulated for one period by multiplying by 1.005. And so in other words, that's the same as being able to calculate the balance just before the payment at time 139 would be whatever that would be what the payment would need to be at time 139 in order to pay it off. So cap Y is going to be the balance at time 138 accumulated for one period by multiplying by 1.005. So it boils down to being able to calculate the balance at time 138, and I can do that retrospectively just like I did before with this equation. So this is the exact same thing that we did before, except we had a 50 instead of a 138. So I'll leave it to you to go through the calculations, and you'll see that the balance at time 138 after that payment of 1,000 is 970. And then I need to accumulate that for one period by multiplying by 1.005. And I get that the Y value, the amount of the drop payment, it would be at time 139. You weren't asked for that, but the amount of the drop payment would be 975.78. Okay, there's one more comment that I want to make here, and that is, let's go back to the original question, which was determine the outstanding balance immediately after the 50th payment. Let's say that I have all of this information now, so that so the point I'm trying to get here is that when we originally did this first part of the problem, we did a retrospective calculation, and now my point is that we could do a prospective calculation now because I have the information going forward at time 50. After 50 payments, or at time 50, I still have 88 payments of 1,000 because I've got 138 total payments of 1,000. So after 50 of them, I still have 88 payments of 1,000 plus that drop payment of 975.78. So prospectively, then I have the information. It took me a little more. It took me more time to get this extra information, but I do have this extra information, namely that the amount of the payment at time 139, that drop payment is 975.78. So prospectively, when you're calculating the balance out of a loan, you just take the present value of the remaining payments. And so symbolically, that present value of the remaining payments will be 1,000 times an A angle 88 plus the 975.78 times a V to the 89, because I need to discount the 975.78, that $975.78. I'd have to discount that 89 months to get back to time 50, the time 50 valuation date. Okay, comment about this particular calculation. The last expression that you see there, the way that it's written right now, that's a two-step calculation using the calculator, the TVM buttons, because I've got an n value. I would be using an n value of 88, but I got a v to the 89th power. So I want to show you a little trick, though, that you can use to make this a one-step calculation. You can peel off one of the factors of v on the v to the 89th and group that with the 975.78 and write it this way, so that now I have, using an n value of 88, I have an A angle 88, and then I have that V to the 88th. So what comes in front of the V to the 88th, I can think of just the future value. So you do a little calculation, prior calculation to get that 975.78 times V, which in this case would be, the V would be a 1 over a 1.005, 1 over 1.005, and get that as your future value, and then that's a one-step calculation again in your using the TVM buttons. And I'll leave it to you to show that you're going to get the same answer as you did before. So there were two ways here. Now that I know what the drop payment is, there are two ways to get the balance at time 50. A retrospective and a prospective. But of course, with the original problem, the retrospective method was much easier, much more efficient to do, because with the prospective method, you would have to first go through and calculate what the amount of that drop payment is, and that's just going to take you more time. So the way the problem was originally worded, just determine the amount of or determine the outstanding balance after the 50th regular payment. I would not do anything with the drop payment. I would just do a retrospective calculation. Okay, so we'll look at some more examples in the next few videos.